Hey everyone, today is the day. I'm moving forward with the matrix, with the 3 by 3 matrix, because I need to explain the rotation also. In the last video, I have covered the scale and the direction and how it represent that in a single data form. And today I want to add rotation here also. So to start this video, I will just I have this simple geometry, which is this rubber toy that is facing the positive z axis. So what is happening here? What do we have? Okay, we have this simple data for this um, world space, for this world space, which is x, this is y, and I talked about z, which is depth. But here the world matrix only has three, just say, directions. It gives us direction, right? So I talked about this, and we have x, y, and z. Z is facing in its direction, y is facing up direction, and x we have 1, 0, and 0. This is left to right, this is up and down, and this is our depth. We have this, right? Today I want to talk about how this matrix also represent the rotation, also stores the rotation data. We have another vector which I want to talk about today, and that is for another videos, because we need to, if we want to move forward, we need to understand this first. I'll make it super easy for you. So I have this. Let's say I have this x, y, and this is minus y, this is minus x, right? And let's say I have this geometry. This is our geometry matrix, and it says x, y, and z. I won't talk about z as numbers, because to visualize z we need to have it's a bit more complicated to visualize the z vector. So I will only talk about two vectors, 2D vectors, so x and y, so we can have the visualization much more clearer. So I will say we have x, and this is our let's say this is our local matrix of the object that we just created, and we have it in our world. So this is the matrix of the object, and you see this matrix is the similar as this matrix. The z represent that if the object face is facing the same direction as that. In Houdini we say the object face is always like faces positive direction, positive z direction, and the up and the up, like the top of the object faces the y direction. And here is the default form of when we create any object, and I talked about this in the last video. So we have the local matrix of the object perfectly aligned with the world matrix. We call this identity matrix. So now when we create any object, the matrix of the object tries to match the world, and it perfectly aligns with the world. World is as a base, right? World has a base matrix, and now we have this identity matrix, which is, so whenever you create any object in the world and you put it in your grid, then it always aligns with the world matrix. So we have the identity matrix first. What if I want to scale, rotate, right? And we also have the direction. So I talked about this in the last video, that the matrix stores data, which is direction. this is the core data that we have, its direction, which way the object is facing or which way it's top or bottom. We have its direction, we have its scale. I talked about direction and scale in the last video. Today I will talk about rotation, how this matrix can store the rotational data. And this is like not that complicated, but it takes a lot of cognitive law to understand everything together if you are starting at first. You see, it took me these notes. You can see I was trying to visualize this from, I guess, from hours today, and it started like days before. And I hate when people only talks about the parameters and the channels and the switches in Houdini, because nobody talks about this. Nobody goes in depth. They don't talk about how the data is flowing behind, like behind the scenes. And that's why we have a lot less people that like really understands how the 3D and how the data flows, right? That's why it is much more complicated to be a technical director rather than just an artist who copies the tutorial and just create some simulations, right? But we need to understand the depth. I need to understand like what's going behind. That's why I'm like doing everything, like I'm doing this, right? So we have this. Now I have my object which is perfectly aligned. Let's say its y is aligned with y, the world y, and its z, x is aligned with x. So we have this object orientation right now. Its orientation is different attribute, but I'm saying we have its direction right now. Okay, so we have this and we have x. We know the object matrix right now. What if I rotate this and move it here? So we will have our object rotated from this, so its y will be here. Now y is here and this x will be here, right? When you rotate this clockwise, this is clockwise rotation, so I will say CW, and you see it is rotated in this direction, and you have this, it is now here. So we did 180-degree rotation, right? And we cannot put this radians, this degree, and put it in matrix, because matrix works from 0 to 1. It doesn't store, like we cannot put another unit in the matrix, so we have to convert this into this. So this Houdini do like in like automatically. We don't need to worry about which value, we don't need to do any calculation, but we need to understand how this data flows, right? So we know this. What happened here, you will get its values, and now let's see what are those values. So you will have this matrix and we have x, y. Remember, I'm not talking about z, but it works similarly, but to understand this and to visualize this, I'm only talking about two x's here. So it's y, which was this, now changed, and where it went here. Now the y axis is facing minus y, so I'm saying its value is now 0, -1 and 0, because this is 1 and this is -1, and this is +1 and this is -1. So now we have this, and the x-axis is facing the exact opposite direction it was facing before the rotation happened, right? What if I make another rotation? This is y, this is x, this is x, this is y negative, and this is x negative. Now the rotation happens. Now I'm rotating this vector to, let's say, here. I'm making a 90-degree rotation, right? So this vector is coming here and this is a clockwise direction. We can also reach here by moving anti-clockwise, and I will talk about this later, but first let's understand this. We have this. Now y is facing positive x direction and this positive x is facing minus y direction. So its matrix will be, here we have x, we have y, and remember I'm not talking about z right now, but z is still there, right? This is like we are talking about x, y and z components, right? So z is there but I'm not talking about it, right? Remember this. So now what will be the value? The y is facing the positive x now. So I will say it is facing 1, 0 in y and 0 in z, because z is there but we haven't changed anything in z. Z is 0. X moved from positive x to minus y. So now x is facing 0 in x and minus 1 in y, which is this, and 0 in z. You see how the data changed from positive 1 to now positive x, which is this, and y here, this is x and this is y. So now how y changed from here to here and x is here to here. What if I make another rotation? This is y, this is x, this is minus y, this is minus x. I want to make another rotation and this time I want to rotate this y here, and I will talk about here counterclockwise and anti-clockwise. Oh sorry, clockwise and counterclockwise, or clockwise or anti-clockwise. So I will talk about clockwise, anti-clockwise. So we have two things. We can move from this place to this position 45, or we can go from totally by making this angle, which is the first 90, 90, 90 and here 45. So we will have 315 degrees of rotation, or we can have 45 degree of rotation, right? We can move here by positive 45, or we can first go to minus 90, then again minus 90, then positive 90, then that. Okay, so first I need to check if it's working, right? Yes, it's working. And the mic, okay, it's working. Okay, we have this. Now what will be its matrix? I will just say green or something bright. So I will say what its matrix now. Let's see that also. So now we will see x and y. Just remember this. You don't need to remember it actually, but I know that if I change the direction, this arrow vector, and I move it like 45 degrees at an axis, like from an axis, so the value that gives I get is 0.7 in x and 0.7 in a y. It's about we are using Pythagoras theorem, but we don't need to understand it. But I just know the value because I was like where is that sheet? Okay, because it is here. Because I was pushing through this, and you can see that I was also calculating like what would be the value and what will be not, like how these x's will change. So I will just see, I will making these diagrams to understand it, and I understood it, so that's why I'm talking about this now. So this value will get 7.7, okay, because this is a Pythagoras theorem, so you will get root 0.5, which is around 0.7. You don't need to worry about that. Okay, so what will be the new value? Y is now facing this, so y in x direction is 0.7 now. In y direction it is also 0.7 and z 0, and x will move here by 45 degrees. And what is the x value? x value will be 0.7 in x and minus 0.7 in y, and z will be 0. So you understand now that how this matrix can have direction, can have scale, and can have rotation. Direction and scale I already talked about, and today I talked about rotation. But here is the catch. Matrix doesn't care about which path you take, or which path you took to reach that direction. You see, let's talk about this anti-clockwise path. So when you move from this to this and you go take this path, what will be this vector value? It would be the same. If you see, like it's the same, right? So you will get the same value. It doesn't matter you move clockwise or anti-clockwise. So when you make a change, like in the direction, like when you create an object and you rotate it, right? When you rotate it clockwise, anti-clockwise, you are making changes in the matrix, and this matrix stores different types of data in one single data. And that's why it always, like behind the scenes, it is working in matrix. And we have like many benefits working with matrix, but rotation is a bit more complicated stuff, and I will cover it later when we move forward down the line. So you understood this, like how matrix is calculating and how the value is in between 0 to 1, right? Okay. Now this matrix, this is the really important part, and I will say purple. I like purple. I don't know why, but I like purple a lot. Okay. So this matrix is the master data. It's the master data about object. When you create an object in a scene, matrix tells about its direction, its rotation, and its scale. It also tells about more things, but I will cover it later because I don't know about them yet. So I will cover them later when I learn about those two. So we have this object. So matrix understand it tells us about the object. It says which direction it is facing, which is its front, which is its back, which is its up. So when you make any changes, the change is happening with respect to the world origin. This is the world data, right? Wait a second. This is the world data. So this is happening according to this. This is world matrix and this is object matrix, and it is happening according to this. So if you move here and here, you're moving like in perspective to the world data. So that's why we have world as the base of everything here. But it only says about object. What about points? Because object contains thousands of points, right? An object contains thousands of points. It is made up of thousands of points. So what happens when I do this? You tell me, okay? You won't be able to, because if you can, then why you would be watching this video? But anyways, I have this, right? And let's say I have this vector, which is right, this I have this vector. Now I am rotating this vector, let's say 90 degrees. I'm rotating this vector, let's say 90 degrees, and I'm also scaling this vector by 2x, right? So what would be its matrix? It would be easy to say, like right now, right? So y will face this direction and x will face this direction, right? And this value would be similar, because it will just 1, this is -1, this is 1, this is -1. And now y will face this, so this is x, this is y will face positive 1, y 0 and 0, x will face 0 in x and minus 1 in y and 0, right? And I scaled it by 2 times. So what will happen? And let's say I scaled it 2 times in x-axis, right? Or let's say in y-axis. Let's say y-axis. I scaled this object 2 times in y-axis. So now its y would be double, right? So when I multiply this by 2, this by 2, but we have scaled it in y, not in x, so we won't multiply in x, remember this. We scaled it in y, so how the matrix will change? When you put 2 in the y parameter, right? In the y parameter, like you say x, y and z, you putting scale 2. So how the matrix will change? It will just multiply it by 2 in this form. So what will happen? So you will see your matrix will change from this to positive 2, 0 and 0. Now you see your y arrow, which was 1 here at the beginning before rotation and scaling, now it has become 1 and it has become 2 in the x-axis. Now it is explaining everything here. So matrix works in 0 to 1. This is normalized. We only have its direction, but when we talk about scale, it can go from 0 to like unlimited or in minus unlimited. You can scale down, and the values will be changed according to that also. Now we have this, right? Now really crucial point here, when this matrix only talks about the object, right? What, this is not object, this is object. Matrix only talks about object, its direction, its scale and its rotation. You can store rotation, scale and direction. What about these points? So what happened, like if you ask me, like you are saying the matrix give us the object location, but object is made up of points, and you're correct. And I had this question also. So when this is filled, yeah, this is filled, so I need to make this a bit bigger. Okay, I will just draw, and you see I have another here x, here y, here minus y, and here minus x, because everything is related to this, so you will be seeing this more. Okay, so you say I have this object. It is made up of thousands of points, 1000 points. Metrics tell about this object like direction, up, down, right, and its scale. So what happens, matrix is the master data, right? So what happens to each point? Let's see with an example. And it took me a lot of time to like understand this, visualize this, and I'm here explaining it to you because it took a lot of effort, like believe me, lot of trial and error, and I have now this way I can make it explain, like make you understand this theory. So we have this, and let's say when you drop an object in the grid, you get two things. First, matrix, object matrix, which tells you about its direction, which way is facing, and its scale, properties and everything. Also, it gives you each point position, right, which is in x, y and z. So now we have this P, which is point position, and you have its matrix, which tells you about its direction, its facing. I will say blue, and okay. So you get two things. Oh, it's not visible. Something like this. Yes. So you get two things here. Let's say your P point is here, and its point position says 0 in x, 6 in y, and 0 in z. Now what you are doing, I will say red because red tells us about the local vector. It's just a way to visualize. Okay, we have this. This is our object x and y. It is facing, it is the, what's the word, identity. Yeah, it's similar with the world matrix, so it's the identity matrix here. And this object is facing same as the world because we just pour it here, and its matrix would be this. I will write it here. Okay, I will say green because we can see it easily. Okay, this is the object matrix. We have x, we have y. I won't talk about z because it would be rather complicated. So I will say x is in 1, 0 and 0, and it is 0, 1 and 0. We have the object matrix. Now we rotated plus scaled by 2 and rotated by, let's say, 90 degrees. So we can easily understand this. Scaled by 2. So my question is, what would happen? What would happen to all those points? What would happen to all those points? Right? My question is this: what would happen to all those points, and how they will initiate this change? We have to rotate this by 90 and we have to scale this by 2x. What would happen? This vector will be here, x will be here, this will be x, this will be y, this point will be here, 0, 6. Not this. We cannot say what would be its point position because we don't have its new matrix. This will be our, oh, we are not rotating it 45, sorry, we are rotating it 90. Y will be here and our x will be here, and we are rotating it 90 degrees, and this point P position will be here, right? What would be its new matrix? Let's visualize. We have x, we have y, and this is our new matrix. So it has moved from this to this. We have point position, but we also scaled it by 2 and scaled it in y. Or you can say scaled it in x and y both. So what would be its new matrix? First, let's talk about its matrix before we are scaling it by 2. So we will have y in the positive x direction, 0 and 0, and the x will be facing 0 and -1 and 0, right? We scaled it by 2. What would happen to x and to y? What would happen to x and to y? Its matrix will be positive 2, 0 and 0, and 0 and -2 and 0, right? It will, so the x will be twice as long and y will be twice as long too. So we will have our object would be twice as scaled. What would happen to all these p points? Let's say this p point was, this point position was 6 in y. Now the master data, which is the matrix, is connecting with all those points, and master data is talking to them and saying the object has rotated and the object has scaled twice as it was before. So you need to move in another position. You need to move from this position to another position in order to make that change happen, right? That's how these points will know that the object has scaled, because we need to move those points in order to make that scale happen, right? Okay, so we have matrix and we have our point position. This matrix will talk to them, you have to move in order to make that change happen, you have to move. The object is scaled. The object is scaled. So we have this new matrix. So this new matrix will talk to these point position. These point position says it is in 6. So what will happen here? This is our point position, and how we will get our new point position? We will get our new point position by matrix multiplication by point position, and we will get our new point position. This is how it works. And why this is happening? Because, okay, in this example, you will understand it more clearly when I say this. You had that grid, right? The point was located at 0, 6 and 0, right? You rotated it and you scaled it. Rotation is already here, scale is already here. So how this point positions will move? So now the point position, new point position, let's calculate, let's say what would be its new position if we multiply this by this formula. So we will have our x, y and z matrix, which is not here, and we will multiply this by the point position, and we will get our new x value and y value, which we will multiply by, which add together, and we will get the final answer. So let's do this. So you have this, right, and you have this new matrix, right, and what was the point position before? 0, 6, 0. Let's multiply this in x first, then in y, and then in z, but here there is no z, so we will multiply in both x and y. So what would be the new point position will be here? Let's say what? So the x direction is now saying, we have, when you multiply this, you will say 0, you will say 0, and 0 multiplied by 0 is equal to 0, and it is our x, right? And what y would be our, like, y would be our 0, and 6 multiplied by minus 2, we will get minus 12, and you will get 0. This is our matrix, right? And this is our x, y and z, and when you add these together, you will get your final p position. So what will be the final p position? Will be 0, will be minus 12, will be 0. So this point which was here before rotation and before scaling, now have to shift to this position because of this new matrix. And when we visualize this, you will understand it totally. We have x, we have y, we have minus y, we have minus x, and we had our vector, let's say here, which was 1, right, which was 1 here, and now what, and its point position will be here for 0, 6, 0, right? Its point position was slightly above, I can say it's not slightly above here. Its point position was p, which was 0, 6 and 0. Now it has to move to this new position, which is, let's say, 0 in x, minus 12 in y. So it would be here. So it would be here, minus 12 in y, and x, y is 0. So this, when we moved it 90 degree, okay, actually I made a mistake. When I said I wrote this wrong, so I will just write it again. And you see, we learn from mistakes, and mistakes are okay. I made this, and now I will correct it. What I did, I wrote the new matrix wrong. I simply made this mistake. So new matrix will be this. You see, y has now moved minus, now y has moved 90 degrees, right? So it will face this. So it will face not x, x will face minus 1. So I wrote these opposites. So this will face 0, and this will face here positive 1, and this will face 0 and 0. But here y will face positive 1 and other vectors will be 0, and here x will face minus 1 because it will be here, right? So when this is our new matrix, and when we multiply it by our point position, which was here, so you multiply with 0, 6, 0 to get all those three components. And let's do this, right? So we have x, we have y, and it says 0, minus 1, 0, and it's a positive 1, and it says 0 and 0. Let's multiply this. So we will get our new matrix, and which will be our after this will be the matrix to the points, right? This matrix is talking to these points, and it won't be new matrix because I'm doing each step, but these steps are happening at the same time. So first let's just do the multiplication first. So we will get what? We will get 0, we will get minus 6, and we will get 0, and y we will get plus 12, and we will get 0, and we will get 0, right? This will happen, and now we need to add this. So our final position will be positive 12, minus 6, and 0. And let's do this where it is. So it is here in positive 12, not in minus 12. So now this is minus 12, but here we will get our position of the y, which is positive 12, and the x will move here. So x will face minus 6 because we scaled this twice, and twice in each, not in only single y or x. So we will get this x will be here, so it will be twice as big, and now it will be twice as big. So our x will face here and y will face here. So I hope you understand, but I will not close this chapter here. I will create another example, right, before closing this video today. Let's do this really fast. I have x, we have y, we have minus y, and we have minus x. So how will it happen? First, let's talk about where is this vector. This is our vector facing, and I need to move this to 45 degrees. So we know that, and I want to scale it twice, but only in y-axis. Only in y-axis. And like where is our point? Let's say our point is here, or let's say our point is here in the x-axis, which is at positive 3 in x, 0 in y, and 0 in z. Right, this is our point position. We need to calculate its matrix and its final point positions. So what we will do, we will just visualize this. Not that difficult, right? Now you understand everything. So our x and y, x will be, I told you, 0.7 its value, and so x will be our wait a second, our x will move here, so it will be in minus 0.7, and in 0.7 in x, and 0.7 in x, and 0 in y, and y will be here, which is both positive, so 0.7 and 0.7. right? We have this new, and it's twice in scale in y, so we will multiply this by 12, and the point position, then we will multiply with point position, which is 3, 0 and 0, and 3, 0 and 0, and you will get your final p position. I hope you understand what I said today. This is the concept that we need to understand, but we don't need this calculation, and we didn't do any calculation. We just visualized and how data flows through this. We just visualized everything. So this is it for this video, and it's a long video, I know, but this is the very important steps in matrix. So yes, and I will cover this. I will continue this matrix part in the next video, and until then, I will see you in the next one. Take care.